so, se mi dai il tuo cellulare...
No, ce l'ho su Slack qua. Dov'è che l'hai mandata? Nella chat...
Dentro la chat quella con tutti quanti. Luca Baggio,
No, questo sono io. Direct messages qua.
non c'è una chat molto...
Oh, questo qui.
La nuvola.
Scarica.
Eccola, esatto.
Da quando è che Firefox è così figo con la barra piccola? Hai scelto un tema figo.
Tutto che qui wireless un po' di gruppo.
Carlo? Ci sarà? Dalla porta principale.
Devo andare
Ti va a prendere Cesare. Cesare, vai tu incontro a qualcuno? Stai andando a prendere qualcuno? Ok, allora.
Ci siamo. Peccato che sia sfocato.
Non metti anche dove? C'è scritto che sto.
Arriva, state chiamando.
Scusami.
Francesca.
Francesca,
Ci sono,
Cesare, che altro che sta tornando all'ingresso a prendere. Quindi se dice cercare qualcuno per mandiamo giusto. Sì, dopo il cantiere. Questioni di cruciale, scusate, cruciale importanza, perché visto che è pieno così, noi dopo andiamo a mangiare e bere una birra al Scott Duff, perché c'è un altro che non è qui, che è un esperto di tutte le birre di tutti i posti di Milano. Volevo prenotare però prima, perché sennò è pieno. Secondo voi chi potrebbe esserci? Mi piace? Prenoto per 10, 15, dai, 15, perfetto, 15 almeno. Molto bene. Grazie, ragazzi.
Esatto, state lontani da vedere.
State lontani.
Sì, ho visto. Sì.
Prenota ora, non deve essere vicino. Faccio una tutta male,
Oggi a mezzogiorno ci ho messo mezz'ora.
Se no, quando vedevo
Carrefour portiamo a dire che però
Ciao, come stai?
facciamo una prova.
Ma non sto seduto poi quando
Hai
faccio.
detto che stavi seduto per parlare.
Ma no, scherzavo, non ti pare che sto seduto?
Sì, hai detto.
Vabbè, ma era una battuta, non si sta seduti quando si fanno le presentazioni.
Cazzo ne so quali sono i tuoi requisiti?
Hai mai fatto una presentazione seduto?
Sì, più volte. Se devi fare live coding, cosa fai? Stai in piedi?
Non faccio la
No, questo.
Grazie, ciao, buona serata.
Ti odio.
Sorry.
C'è una partita anche stasera.
Beh, se vuoi stai seduto.
No, tieni su questo. No,
Ma perché?
spero che vada il microfonino lì.
Se non va sto seduto. Se non va sto seduto.
No, vabbè, tranquillo. Io provo a usarle tutte e due in modo tale che se uno non va, switch. Comunque, questo è un buon microfono.
Questo è comunque un buon microfono.
Date solo quello, non te ne vai su.
C'è la barba però che fa disturbo, fa, come dire, fa interferenza. Dai, sto seduto, ma gli mettiamo un supporto però, no? Prova, io continuo a parlare e dire le cazzate, così tu vedi se mi senti. Va bene? Prova, ciao. Mi chiamo Lorenzo Mele. Adesso domani ho il rogito, sono un po' agitato. Sono stressato per tutto quello che sta succedendo in questo periodo. Ok. È proprio online? Bella storia. Ok. Ah, ecco perché ci hai messo un po'. Vabbè, quindi si comincia, siamo già live online?
Sì, siamo live con uno schermo.
Manca Cesare, però. Come mi vedi? Vuoi fare lì?
Sembra in forma.
Sì, grazie.
Ah, aspetta, tieni.
Sei andato in palestra. Vuoi farla tu invece, che sei uno storico? Vai. Cesare. Ah, che c'è? Infatti. Vado io, no? Tra l'altro siamo in... No, vai pure tu se sei... Come vuoi? Guarda, io faccio vedere, però non voglio rubare il posto. Come va l'audio? Ci siamo? Ciao carissimo. In inglese? Che è il bergamasco parlato piano, dicevano dalle mie parti. Oh, ok, ciao, buonasera. Hello, good evening, everybody. Ci siamo quasi, okay, we ready? Welcome to tonight, misplaced meetup. Unfortunately, like a couple of so many events clashing, but thank you for being here. Thank you so much. We're Python Milano. We're hosting a couple of exciting talks, but first of all, let's talk a bit about us. We are Python Milano. We are a community open to developers and hobbyists who have fun with Python, but do not only code in Python. We host two kind of events. We do actually three. We have the in-place meetups and PyBeers, which are quite popular, and there will be one coming soon. But we also host a podcast. Cesare and Marco is not here. Ciao, Marco. Are hosting one every 3 weeks. Intervista Pythonista, which is a format, a really nice podcast where they pick up an Italian Pythonista and put it on the stage. We've had lots of success, lots of really interesting people coming to us. The latest one being Marco Gorelli, maintainer of Pandas. So if you want to know everything about Pandas 2.0, Arrow, blah, 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 go check that out. And if you want to join us and stay up to date with what we do, you can join us on Slack. If you go to milano.python.it, you will find a code to join the Slack group. And if you need to write us on an email, etc., you can find all the contacts there. And as always, it's okay. Thank you for all of our previous hosts. A really big thank you for Mirta for hosting us like countless times. If you want to say something after that, you're more than welcome. But also to your previous hosts, people from Octopus, people from Futura, Crafted Software, we're always very welcome to join, to let us in and host our events. Without further ado, then if you want to say something about Mirta, yes, please.
Hi guys, welcome. We are really happy. First meetup in 2023. So with us, with Mirta. Doors are always open for you. It's really nice to see you again here. And nothing. Very quickly, we are a startup in the fashion industry. We are selling made in Italy products all around the world, especially to boutiques since this year. And we use a lot of Python and lots of technology. So we're always interested also in the topics that you bring to us. Yeah, I hope you enjoy the session of tonight. Thank you for coming.
Thank you, Mirta. Once again, we're starting off pretty strong with Lorenzo. He will be talking about CI/CD pipelines, and good luck with it. Sorry? Everything about them. So, like, if you need to come out of here, it would be gurus, right?
Yeah, of course. You'll see. Okay. Here we are. Okay. Can I start? Okay. So, welcome everyone. It's nice to be here. I'm Lorenzo Mele, and I work for Octopus as a Python developer. I'm not an expert in CI/CD pipelines. I just wanted to know more, and I like to make fun of myself. So here I am in front of a crowd. Let's start. CI/CD what? So what is CI/CD? CI/CD is just a part of software development lifecycle. This is the software development lifecycle. In essence, of course, if you're using some sort of agile, it will have more arrows, but basically these are the main phases. Back in my days, probably even sooner, all of this was manual. But since our job is to make people redundant, is to automate things, we started automating all that was possible to automate. So basically, once the code is done, we can run everything automatically up to the deploy. And this is the CI/CD focus, because all of the other phases are manual yet. But let's see what exactly CI/CD acronyms means. It's composed by two stages. Both stages have the C, and they stand for continuous. This means is a continuous process. It should run continuously on the code base at every commit, at every push, at every merge, always. The I stands for integration. This means that the first phase is focused on integrating fast and frequently. In other words, continuously. Integration means that your code is merged quickly in the main branch, and we'll come back on this later. D stands for delivery or deploy. After all the rest is done, the code should be shipped into production, or we need to produce a deliverable. As for the previous stage, this is continuous, so as soon as the build is done successfully, the deliver deploy must be done. Now let's focus on the first part, CI. We want our code to be in the main branch as soon as possible, but where do we put our code? We need to write the code and store it on a source code management system. Which one? The main source code console system are Git, Subversion, and Mercurial. I needed to choose one. I asked ChatGPT, and apparently there are no main differences between these, but we need to choose one anyway. So by process of elimination, since I don't know Mercurial, and we are no longer in the 90s, so I will continue the presentation using Git. Okay, where do we want to store the code? We can do all of our laptop, but we can also do everything in the cloud for free, so why not? The main free online source code management systems are GitHub, GitLab, and Bitbucket, and we have plenty of other services. So I needed to choose one of them, but since we are in a democracy, I continue the presentation based on what you'll choose. Should I continue with GitHub, GitLab, Bitbucket, or one of those? Say that? GitHub. Good choice. Okay, it's GitHub then. Let's dig into the code. So one way to set a CI/CD pipeline on GitHub is to use workflows. Workflows, we'll see how they work, but in essence, it's just to define a workflow is as simple as creating a YAML file in the .github workflow directory. The name of the file can be anything. I call the first one CI because we are focusing on the CI, sorry. Then we set a name of the workflow, in this case, again, CI. Then the trigger, so when the CI should start. The workflow can be used for any action in GitHub, like tagging an issue, adding content to a PR, and so on. For our case, we want the CI to run after each pull request and push. Remember, continues. So we define the jobs. We can define more than one job per workflow. Each job is a set of steps, basically. We can have more than one job, and they will be run in parallel. For example, we may want to run unit test and integration test in parallel. So we name our job. This is actually the job's ID, not the name. We can set a property with the name, but we are backend developers and we are not scared about names without spaces. And so we need to define the attributes of the job. The first attribute is runs on. It defines the runner. Basically, in other words, it's just a machine where we want to the workflow to be run. We can define one or more runners, and the workflow will run on each one. So let's define the steps. First, check out the code. For each step, we can define a name. It's not mandatory, but it's nice to see in the pipeline all the good descriptions. In this case, we are defining an action, basically. An action is a piece of reusable code. It could be available on GitHub itself, like in this case, or it can be something coded in the repo itself, the repo we are using. It's always a good practice to pin the version. You know why. Then another step and another action. Then we run the command to install all the dependencies Here we are not using an action, but a command, pip install -r, usual command to install the dependencies. This command will be executed as a shell command in the Ubuntu machine, as we defined. And finally, we can run the test. Is it all clear? Am I running too fast? Probably yes. Okay, so that was one example of what we can do in the first stage, but what about the delivery? Let's pretend we want to publish our library to PyPI. So we create a new workflow named CD. What a fantasy, right? This time we want it to be triggered on push only for main branch. We can define multiple branches. For example, we can have main, development, and so on. And this workflow will be basically triggered when we merge our PR on this branch. Okay, then we define our job. It's called delivery this time. In the steps, we might want to execute the previous CI workflow, or we can call the other workflow from within this one itself. But for simplicity here, I'll just pretend we are running all that we need. And then we build the package using the package, Python package builder. Then we need to finally publish the package, finally deliver. We have the D. We'll use another action, defining a proper repository. As I was mentioning before, we can use a GitHub actions, but any actions, even the GitHub actions, in the end are just repository on GitHub. So this pypa/gh action pypi blah 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 is a repository, and this v185 is a tag on that repository. So we can call it, and in this case we can also call it with parameters. This case is just the password we can use. So this is to explain that every step can be called with parameters, and as parameters we can use variables. These variables is set as a secret in the GitHub project properties settings. So that's it. This is the CI/CD. You don't need anything else. It's just a way to test and delivery, isn't it? Or we can do anything we want with the CI/CD. We can do static code analysis like MyPy, security, all that stuff can be a step in the CI in every workflow that you want. You can execute these steps during the any push, or maybe just before the merge, you choose. You can even run lint formatters. Anything you can run on your machine can be run also on the pipeline. You can run code coverage. You can even get a report, and maybe you can set a threshold under which the code coverage will return error and thus fail the pipeline and thus not deploy. And if you have that, maybe you just want to run the code coverage and deliver the results, you can deliver with notifications via Slack, via whatever you want. You can check merge conflict before the PR is even merged. You can enforce policies like me and Pietro the last time spoke about layer architecture and how we enforce the layered architecture, so importing stuff from one layer to another. You can check commit messages, really, you name it. And that was it, really, this time for real. It was very brief. As I told you, it was just a way to explain what I discovered about GitHub workflows. Questions? Yes?
I was curious about the CI part, and where you can define like which you define in such a way that, for example, you run that on every single development commit, then it would sound like too much to pull an Ubuntu server image every single time and build on top of that.
So I don't know for sure, but I'm pretty sure that GitHub is caching the image. And I also tried a local command to run the GitHub workflows. It's called act. Okay, you know that? Cool. It's called act. It doesn't work very well with the M1 processor, but I saw that basically it's using Docker. So it's downloading the Docker image of Ubuntu and run everything on that. So it's just cached.
Maybe slightly less relevant quiz question, but there are also actions that allow you to cache specific stuff in case you made it to this format.
Yeah. I don't know the details, but yes.
I was curious about the tools for static analysis and security.
Okay.
What do you
recommend? Well, MyPy for sure, but also one of the nice things that you can do is to run the pre-commit. If you're using pre-commit, there is an action to re-execute the pre-commit on the pipeline. And so during the pre-commit, usually I run MyPy, what else? Flake8, Black, iSort, so everything that check the code, what else? Security, checking the security of the packages in order to see if there are some vulnerabilities in the versions I'm using. Yeah, more or less that. And code coverage is a good choice.
It's because there is this tool called
PySA?
PISA. Delivered by Facebook that do an active code navigation for searching for security bugs. I was wondering if anybody.
Wow, I didn't know that. I will look it up. Yeah, cool. There were, yeah.
I was wondering how are you handling the releases of version management? At this point, you decide on some major release, minor release, but
okay, the question is, how am I handling the version release? Versioning, you mean updating the version in some file inside the repository? I never had this problem, and I think it should be something that you run before the commit as a maybe pre-commit hook, because I don't like the pipeline to change the code. I like it to check that the code was so if I'm running Black in the pipeline, I'm running it to check if it's respecting the Black style, not to change the file.
Okay, like the suggestion is like using a third part, like storing in a database somewhere.
Oh, maybe, yeah. You can definitely, at some point of the pipeline, get some information from the code base or executing some part of the code and deliver the message whenever you want. As I mentioned, you can notify using any services online, so you can actually, once you have the connectivity user and the password, you can connect to any service on the web and deliver it. Yeah, go on, Pietro.
I can tell you what we do. We have two repositories. One is for festival, the other is for deployment. And there's a version. Yes, we don't use semantic version, so it's easy. But every time we merge the master, then a step of the pipeline is to bump the version in the repository, which then is merged together. I don't know why. I don't know how, but
okay.
They get it wrong.
I repeat for the online people. So in Octopus, we are using this version bump whenever a deploy is made on master, a merge is made on master, and we are about to deploy, we are bumping the version on another repository. It's just a counter, so it's easy to handle. Thank you, Pietro.
So this is one problem, Python 2.0, and something crashed from your last push, and then you get crazy and realize that it was a little final. So how do you handle or you hinder all the dependencies, but that's sometimes crazy and keep your code outdated, or how do you handle the code failing because of an updated dependency or because of your own mistake?
Okay, so the question is, how do I handle code dependency failures? Okay, I would say pin the dependencies, pin to a specific version.
Yeah, but I think in your pipeline, then you have the problem that if you use that, then you need to, after some months, you all have all dependencies, and then you have automatically updated that you have a code that someone else.
Okay. I think there is a package in Python. Yeah. I think there is a Python package to check the version, if there is a newer version for all the packages. And so maybe you can depend about. Okay, yeah.
And so basically, if you do not,
can you come here?
So for dependency checks, if there should be a requirements.txt there, well, technically, hopefully at least. So when you do the step in the workflow, then you say pip install -r, okay, then you install from the requirements. And then if people manually update the dependencies and do not sync it with the requirements, of course the code will fail and it will be not to be bumped. But there are actions to actually check all the packages. Dependabot is a popular one. It was like a service on its own, but then GitHub bought it. And then it can check if you use Python. So it's also like a small YAML file that you put not in the workflow directory, but there basically. And then it will run whenever you want it to run, maybe once a week, for example, to check whether the dependencies can be. Actually, we'll check it like in real time, and we'll also check against the security breaches. And we'll recommend you how to update your requirements file to the latest version if you're interested in that. See?
I think that
Sì, dai, che.
I don't want the pipeline to update my dependencies.
Oh yes, that's also another thing.
Okay. Usually, I don't want the pipeline to update my dependencies. If I have outdated dependencies, I update the dependencies in my local machine. I test, I run the script, I run the test, and then when I'm sure, I will push the upgrade to the pipeline. I don't want the pipeline to change a version of over the dependencies without my control.
So can you hinder every dependency and then time to time?
I pin usually I use a package manager. There's Poetry, or you can do it directly with pip, and you pin the dependencies, and then from time to time you can upgrade your dependency locally, and then you update the pinned dependencies. But I think you don't want the pipeline to automatically update the library. Why? It's risky. You can do it, but it's risky, I think.
I mean, if I want to use your library and you hinder all the dependencies, and then they are not updated because you didn't have time or it's another repository, then it's crazy because my environment is
But
you don't pin the dependencies of the libraries.
Okay.
You pin them only in final application.
Okay.
Yeah. Exactly.
Yes.
There was another question, I think. No? Okay, fine. Thank you very much.
Mi ha inviato la mi ha fatto il link
No, non trovo. molto facile. Vai su Venezia, Domodossola, Otranto.it.
Video.
Scritto un OBS, condividi il tuo schermo come preferisci.
Sono già collegato a quello lì, quindi faccio quello lì.
Ora
No, di source non ci interessa.
questo link qua
Devo giro su Slack.
ok.
Se ce l'hai,
Sì, ce l'ho, però devo prima a leggerlo. Leggimi solo il finale qua, il codice dopo il quale.
MQ,
Aspetta, minuscolo. MQ minuscole.
sì. B maiuscola, Bologna maiuscola, 2-6, Roma 8. Scusa, Roma maiuscola.
Roma maiuscola è
8.
8.
Sì.
Invece lettera. MQB2, 6, R8, Roma e Bologna.
Esatto.
C'è una volta di adrenalina.
Ci siamo?
Sì.
Aspetta, ce l'hai il microfono?
No, ce l'ho.
Attaccatelo se riesci.
Anche proprio al colletto.
Sì, ma... Come si vede? Ma...
Considera che prima Lorenzo ci aveva sotto la barba. Perché il microfono prima ci aveva sotto la barba.
Aspetta un attimo che... Ok, ci siamo. Ok. Okay, thank you everyone for being here. Thank you for to the Python Milan organizers. So this talk that I've named FastAPI and SQLAlchemy 2.0, name a more Pythonic duo, was inspired initially by the 2.0 release of SQLAlchemy, actually, even if it mentions FastAPI in the title. But to give a motivation behind the SQLAlchemy 2.0 release, I think it's important to go from to see a bit of different kind of stacks that we could imagine in the Python ecosystem for the backend. And in particular, we are going to go through a series of frameworks, including Flask, FastAPI, and even some TypeScript oriented framework. So just briefly about me. So I studied, I had a mix of education between economics and CS, a bit of unconventional and a bit of ML. But I've been mostly working with web technologies and some data, of course, data related, given my education. And currently I'm leading the engineering team at Quick Algorithm, which is a startup based in Milan. And we work in the, we do a SaaS software in smart manufacturing, digitalized maintenance, and this kind of stuff. You can find my contact if you want to argue with me about the presentation later, or you can do it in person. You can argue with me also about other stuff. You're free to do that. And also, if you want to get the link of the presentation, it might be useful if you want to check references or stuff like that, because I have some links around the presentation. Better to take the link and save it so that you don't get distracted. But yeah, it's good. Okay, so at the company I work for, we have Python APIs, a backend in Python for our main application, and we are pretty envious of other technologies, other web technologies. You know that we are in Python Milan, but Python is not the only language out there. So we've been, sadly, we have been looking at other stuff, and they are pretty cool. For example, we saw how they make Go APIs and Go backends, and they are very fast. They're very concurrent. Go is a very nice language, and also Node is everything in Node is async by default. So probably if somebody of you saw the previous Python Milan talk, you saw all the benefits of async and how it helps our web applications. And also, of course, TypeScript frameworks, given that if you start programming TypeScript, you are using types, are very well integrated, all the frameworks with the typing system, and it's a bit more advanced than Python, I would say. So I'm a bit envious also of that. You might say, why you choose Python if you care about types, but yeah, I try to make something out of it. So in this presentation, we are gonna do first, gonna look at what I consider an ideal TypeScript stack. Of course, there is nothing ideal. It's just an example that tries to prove my point. And then we're gonna try to build up our Python competitor. As I said before, if you're looking for an async primer and more discussions about async, the talk of last month was much better in that regard, and it's much more complete. Also, a nice bonus is that there is a working GitHub repo of everything that I'm going to show in this presentation, and the repo is much bigger than what I'm going to show. I just try to build up the various stacks for it, and if you want to go in more deep examples, just go on that. And also some warnings. As I said, there are a lot of ways to achieve the stuff I'm going to show in this presentation. In particular, one important thing is that I'm mostly focused in my experience on Flask related stuff or FastAPI, so I don't know that much about the Django world. I know that there are frameworks that try to achieve similar stuff. For example, Django Ninja is a framework based on Django REST framework, and it's fully async and with types, and integrates very well with the Django RM. So if you are in that area and you play with Django RM and so on, maybe something like that could be slightly better if you go in this direction. Also, I made some very ugly Excalibur sketches around the presentation. Also remade some logo in dark mode. It would be easier to just replace the colors, not remade in Excalibur. And of course, this is going to be all irrelevant in a few months when there will be some new Rust-based frameworks that will spawn in the Python ecosystem. And again, previous Python Milan talk by him was exactly on Rust packages for Python. And of course, if a language model fires us all, this is all irrelevant because who cares about the developer experience at that point. Quick digression, why type safety? This is going to be very quick. And it's essentially type safety allows us to find problems in our code earlier and detect inconsistency in what you are saying in our via code. And in particular, like this is a very famous screen. I don't know, you can't read anything, but it's a famous screen from an Airbnb presentation saying that about 40% of their code in their post-mortem analysis would have been prevented by using TypeScript in this case. But of course, this is generalizable to any type-safe language or type-safe feature. Type safety not at 0, 1. You might have various degrees of type safety in your code. For example, like Python is, as we know, is a dynamically typed language, but since 3.5 started introducing type hints, which are optional typing features. And so they started developing tools like MyPy, which was mentioned in the previous presentation. And so from Python 3.5, we have this. And in this, the original proposal of that, they also remarked that Python will remain a dynamically typed language, and they will not enforce it even by convention, meaning you should expect to find frameworks and stuff that have no types. So we need to live with that, and we need to make compromises knowing this. Now, going to alien stuff, TypeScript. So I tried to build a small application, a to-do list application, very, very simple, just to show some technologies that are available in the TypeScript world. In particular, I built it with a Node.js, of course, server, TRPC and Prisma, and we're going to see what are those. So first point, already remarked, Node.js is fully async. It has an async event loop. And basically, the main point of async is that our workers can spend time doing actually useful stuff and GPU-bound stuff, not just waiting on input-output, waiting for your database queries and those kind of stuff. Still, another reference to the previous talk. And another library that I added in this stack is the TRPC library, which is basically, it's a library to sync automatically the types between the front end and the back end, so that there is no code generation step in between. So you can, as soon as you change the types on the back end, your TypeScript back end, immediately you will have errors and linting problems on your TypeScript front end. So this is very nice. Yeah, you see here on the, wait a second, okay, no. On the left, there is a server side, and the person is changing a name of a property from message to name. And what you can notice when he changes it is that on the client side, immediately you get a linting error. So this is a very small thing, but it's important for a lot of reasons, including why sharing your API types is very good. First, you do less errors because you have less code to write. The types sync automatically between the two. And also there is less communication between the front-end team and the back-end team. And that's, I guess, very important because it's everybody's more productive. Another addition to this is Prisma, which is, again, an ORM in the TypeScript world, but it's very nice, nicely integrated with TypeScript. You get for free all your interfaces, types, and you're sure that what you're giving the database is what it expects. And for this, I made a quick, just to get to know our app. Wait a second. Okay, so this is the app. It's a very ugly to-do app. And you can basically have a couple of features. Just you can edit the to-do and just save it. In this case, it's a stateless. So once you refresh, you lose all the changes. But I basically built different types of backends for our implementation, and this you can find in the repo, so that you can clearly see the differences in implementation. So, sorry, I don't see very much the mouse, but yeah. So this is of course, the TRPC, which, if this works, it's implemented. And we're gonna see the stack now. Okay, I probably need to zoom a little. Okay, basically, what we do is we define the kind of schema of our to-do. In this case, there is an ID, which is the incremental ID of the database, a title, and which is a string, and a completed, which is a Boolean of whether the to-do has been done or not. And this is how you basically, very shortly, how you code your interfaces. So you have, for example, an edit to-do mutation that allows you to edit an individual to-do by passing an ID. And here you have the syntax. I don't particularly like this syntax, but that's not the point. Here is the way to edit the to-do on the database. ORM type safety means that if I am editing the title, and instead of passing a correct string, I start to pass, for example, a Boolean, I get immediately a type error saying this. So type false is not assigned to type string, essentially. So this is pretty basic. But the other nice thing is that if you try to look at the front end of this, the implementation or the calls on the front end are very basic in the sense that you create this client. This is all available in the quick start. It's very easy to do with the correct URL. And then you have immediately available all the methods with also the types that you're supposed to pass. I didn't code these methods. They are automatically synced between the backend and the front end. And to see how these are synced, you can essentially, if we replace this edit to do with edit a to do, for example, we are going to immediately see a linting error here. So this is a pretty nice developer experience, I would say. You get errors immediately. And also, we need to remember that the web server is running on Node, so you can get a lot of async advantages and non-blocking I/O. Now, going back to the... Of course, you're not here for the TypeScript meetup, so we need to provide some alternatives for Python. And so we can start with the most basic stuff that we can imagine, which is Flask. Flask is called a Python micro framework because it tries to allow you to do a lot of stuff with it. It's not so constraining, so you can put, of course, a lot of stuff on top of it to make it better. And but two of the characteristics of Flask is that it's generally untyped. So unless you put something on top of it, every type that you receive from your request is gonna be any. You don't know what is that. And also is generally blocking, so it's a synchronous framework. They started introducing some sync features in the latest versions, and there is a fork of this called Quart that tries to make it fully async, but the bare version is not. And also, as the ORM, instead of Prisma, I picked SQLAlchemy. This is, I don't know if Django people are gonna hate this, but I personally like a lot SQLAlchemy. It's okay, it's a nice ORM in general, and we're gonna see a bit the characteristics. So first detail, now we need to perform all the validation on what we receive from the API. So if we receive, in this case, a request, and I just do request.json in the simple Flask life, you don't know if that JSON is what that JSON contains. So if I start to edit, for example, the completed, I also need to check that the completed is actually a Boolean variable and not a string, a number, or something else. Of course, this is Copilot trying to complete it. I don't know. Do you usually check it with in true false, or you do with instance or stuff like that? Yeah, yeah. No, but this you can set it also to false. So, but yeah. But okay, Copilot. Yeah. So you need to perform anyway the data validation. You can use something like Marshmallow or Flask API specs that allow you to perform some of this validation in a more easy way without implementing basic stuff every time. But the syntax, to me, it's very ugly, and it's not really fitting with the type-ins story and how generally type-ins work in Python. And also, after we have performed all the validation, your front-end developer can still get stuff wrong. It can call the endpoints with wrong types, generally a wrong request, not even calling the right endpoints. And so you might commit error, and you need to communicate with him in general via documentation or whatever. So I implemented also this as a, okay, I'm gonna spare you the Flask implementation, but the important part is that the Flask front end now looks like this. I've defined all my functions to get the to-dos, edit the to-dos. I manually specifying the types of these just to perform this request, and there is a lot of boilerplate for the creating a JSON to send it to the endpoint and blah blah blah. And now then you can pass this to the component. But the thing is that, of course, this leaves a lot of room for error, and compare it with the one on the right, where you directly use the already implemented stubs. Of course, if the API changes, you need to make changes, so it's more work. Also, another problem, SQLAlchemy might be very cool, but before the version 1.4, no, before the latest version 2.0, SQLAlchemy doesn't provide type hints for what you are retrieving. So if I do a simple query like that, it's going to be an any. And also the various columns that I'm taking from the object, unless I tell him, look, this is a to-do that I've queried, are going to be untyped as well. And this is another additional room for errors, in the sense that if I start passing instead here a string instead of a Boolean, it might incur other problems, runtime issues, or stuff that are not so easy to catch. While if you have a bit of typing, it's all clear. On top of this, as I said, we have blocking I/O in, for example, database queries, which is usually in a web application the most I/O intensive operation is querying the database. So you might, of course, have multiple workers, multiple processes, multiple threads serving these requests. But these workers, when they encounter a request that goes through the database, needs to stop and wait for this I/O, unless, of course, you implement some different system on top of it, for example, async. So we can start to define a kind of quadrant of type safety on two axes. One is what we could call API type safety, so sharing types between the front end and the back end, having them synced and correct. And the other one is ORM type safety, so having correct types between what is implemented in the database and what we have in the code. And of course, Flask, in this case, is the worst performer, that stack that I presented, and TypeScript is very good at both of those. But given that this presentation was not complex enough, why not add also sync on the axis? So we have also a 3D visualization, and where the TypeScript stack also improves on that, because Flask is mostly sync. So how do we fix this? Our first player that we can introduce is FastAPI, which is, I would say, very similar to Flask as a framework, but it comes with support for async straight away, and it's also very well integrated with type hints and generally type validation. For example, the main library that it uses for type hints and type validation is Pydantic, where similarly to what I showed in TypeScript, you can define basically a schema of what you expect from a request, from the database, from multiple places. For example, this config is specific so that it knows that when it needs to return that and it receives an object from the database that's compatible, it's going to let it go and convert it to a proper JSON. Pydantic does both the interpretation of a JSON into an object with the correct types. It does also some kind of casting. You can play around with it so that it does typecast that you like, and it's very well integrated with FastAPI, because, for example, if you tell it, I want this endpoint with this request that has this schema created to do, which in our case will accept a title string, then automatically we get for free the type hints on the request. So we know exactly what we're getting. And Pydantic, if it receives something wrong, stops a ready request at the beginning. It just stops the request and tells exactly what's error. You were supposed to pass me this, you passed me that. So once you have that in place, you are pretty safe to then trust these types. Wait, I want to add. Okay, so I have a problem of syncing between the two. Okay, another thing that you get for free in FastAPI is that now you have defined everything that you are accepting with precise types, and you are also defining what you are returning. So you get for free all the documentations of your endpoints with precise types of all of them. Now this is very blurry, but it exposes all the schemas with what it's expecting for a certain request, and also if there are defaults or if it's mandatory, other types, every information that you can get from the types essentially. And then there is a nice playground there. You can play directly with the requests. But if we said that there is an automatic OpenAPI generation. OpenAPI is a specification for web APIs where it describes what kind of stuff it can accept in the various requests. But if we say OpenAPI, we open up a very nice word, which is the code generation. For example, if you have a front end in TypeScript, you can use a library like OpenAPI TypeScript CodeGen and automatically retrieve from the generated OpenAPI spec from FastAPI, retrieve that and generate automatically client stubs to have precise requests from your client. The documentation of FastAPI is very clear about this and talks about a lot of specifics. We can look at this as well. Just to get a feeling of how FastAPI looks like. Okay, ignore this boilerplate, it's a bit of stuff for the OpenAPI generation. We defined our endpoints, and for example, in this get-to-dos, it's simply an endpoint that returns a list of to-do schema. This is, you see, it's 100% integrated with types. We are not even returning a to-do schema here. We are returning a to-do from the defined database. But given the ORM mode that I told about earlier, it's going to convert them automatically and know that it's a correct operation to do. Then, as I said, we can accept a request and blah, blah, blah. If we go back here and now I need to type the right URL. No, this is not the correct URL. Sì. So these are the documentation I was talking about before, and but this is okay, very very nice. You can play with it without using Postman because you have also a tryout feature. It's integrated also with authorization. If you have, for example, a kind of bearer token authorization, they allow you to pass it directly here to play with it. And let's look at the front end. I have a nice script on my front end called generate client. Your front end developers are gonna love this because you can, with this library called OpenAPI TypeScript CodeGen, directly take from the endpoint of FastAPI the OpenAPI JSON spec and output a FastAPI client, which is a TypeScript client. In this case, it's in this directory. This directory is fully auto-generated. I didn't touch it. And so our implementation of a FastAPI backend becomes very, very easy. As you see, I imported this default service. It's just because I put it in the root path of FastAPI. You can do sub-routes and have more nice names. And I get automatically these kind of functions that under the hood perform all the relevant calls and the JSON serialization and so on. And as you see, I get also some information about what I'm supposed to pass. In particular here, okay, this title comes from another place and it's a string, but if I change it to be a Boolean, I get another type error. So again, this is fully typed with TypeScript. And this is essentially the only code that your front-end developer can use because they now have this service with everything implemented. They don't need to do anything. The additional step compared to TRPC is that this needs to be regenerated with the command if something changes on your backend. This is, of course, you can make some utilities so that this gets done automatically, maybe. That's a possibility. Yeah, I don't know about, maybe, not sure about that. Yeah. And but of course, I mean, if you are in TypeScript both on the backend and the front end, you are gonna for sure have some advantages compared to having something else on the backend. We cannot be perfect with Python on the backend, but this gets pretty good with it. Yeah. Also, the thing that I've not been talking about is that FastAPI, as I said, is based on ASGI, which is the new standard for it's not new, but recently getting implemented by a lot of frameworks for async web servers in Python. And in particular, it's based on a lot of other libraries, as I said, Pydantic for the validation. Starlet is the main web server that powers FastAPI. And also there is UVcorn, which is the actual web server that runs it. But not so fast. If you, I don't know how many of you have paid attention to my code on FastAPI. There was an interesting detail there, is that all the functions in the FastAPI code that I showed before were def, normal def functions. So if you know about async function are prefixed with async def, name of the function. So why I didn't do that? The main reason is that SQLAlchemy, with a version less than 1.4, which was just a bridge release for 2.0, doesn't implement an async interface natively. So either you switch to another async ORM, or you need an adapter like encode databases. But if you are just on SQLAlchemy, it's not suggested to start using it as if it was async. So if you start to use async functions in the FastAPI framework and you have blocking I/O, it's going to block your entire event loop. While if you name a function in FastAPI like a normal def, it's a sync function, it's going to be intelligent about that and put it in a thread pool. So this is very important for performance reasons. So this is bad. We had solutions like adapters, but I don't know, we like something better. And still, we still have the same problem as Flask, that we don't have types because it's the same ORM. On the ORM, we still have SQLAlchemy, that kind of SQLAlchemy. So if in our travel to the top, we advance a lot on the API type safety. We basically reached the level of TRPC with additional trouble of clicking a command to generate a client. And we slightly improved the sync, but the problem is that most of the calls are on the ORM. Most of the web APIs calls are using ORM as I/O. So this improvement, okay, we can say, yeah, we have a sync, but we are not using it for most of the stuff, most of our I/O. So not a great victory. So here it comes, the main focus of the presentation, which is SQLAlchemy 2.0, which was released at the end of January of this year. And it brings a lot of improvements. We can go through them. First of it is the type ints. So they basically re-implemented a lot of stuff so that the types in the ORM are native. So now, finally, when you do some kind of query, you're gonna get back that this is a sequence of to do and not just an any. So we can play with it. And also, then it's also in the various variables, you can have the various properties, you can see what type they are. And of course, if you start passing now the wrong thing to that, it's gonna complain. And that's much better for error prevention. Also, as you already see here with that beautiful await keyword, they introduced the native async support, async I/O support. So that's very good for performance, and we can start finally convert our application to be fully async. There is a link to a guide here that gets into more details about this, because now I made an implementation. It's very not production ready. It's just a demo. So the backend, the front end now it's identical because the interface didn't change, but we can start to see some of the interesting stuff that comes in the SQLAlchemy 2.0 release. These little keywords tells us that our base is a data class. So you come with nice utilities with that, like a constructor that is more informative of what you're building. You get automatic string conversion to represent your objects and all the stuff. The syntax also slightly changed. I mean, it's mostly backwards compatible with the old one, but now we have this mapped keyword where you can get to very simple constructs where you, even if you just do a mapped boolean like that, even without this is just to set a default. This is basically it to get a boolean. Now with that, you're gonna add a boolean on the ORM, so it's very clean syntax. If you, the previous SQLAlchemy syntax had a column construct with the type and additional stuff. And you can, okay, this is an interesting thing to show. I forgot to edit one thing here. So I define, this is a feature that is being used quite recently with also some updates in FastAPI. But what we can do here, annotated, is a feature of typing that allows you to annotate a type, for example, in this case, int, with some runtime stuff that frameworks or libraries or other stuff can interpret in some way. So if we, for example, annotate int with this mapped column and we call it a primary key, we get back a new type, which is an int primary key. And now the beauty of this is that we can completely replace this with int pk and get rid of all of this. So you can reuse int primary key across your whole application, and the syntax is going to be very clean. This is mostly good for type reuse, stuff reuse, and it's not crucial. Now, there is some black magic related to async session creation, and I don't expect you to understand the details of this during the presentation. But essentially here we are creating a function that returns sessions, async sessions. And now another nice part is that we can, if you're familiar with FastAPI, you will know that this kind of dependencies, like a session or so on, you can pass them to functions in FastAPI through the depends keywords. The depends keywords allows you to define a function or whatever, all the dependencies. Again, reusing annotated, this is a very recent release of FastAPI. You can annotate the type async session with the dependency, which is the function that we defined before. And now you can simply pass this DB session type to all the endpoints that need the session. And this session, FastAPI is going to resolve that dependency automatically at runtime. And this is incredibly good for testing, because you can, it's very easy to mock all the dependencies in your, when you're testing a FastAPI application. That's the main reason for the dependency system. And yeah, the code is still pretty simple. You get, as I said, the additional type ints, and you can still play with it and see that there is a title, and you can, that's also a string 30, so you, and it might be also null. That's all nice to know. Okay. Of course, the FastAPI thing is working. This is probably the FastAPI with SQLAlchemy 1. With SQLAlchemy 2.0, you will see that I got a bit too excited on the FastAPI world, and I did not implement a delete function for my to-dos. So, but I got excited creating them when it was working, and now we are stuck with this situation. So yeah. So thanks to SQLAlchemy 2.x, we got to the same on this totally arbitrary octant of what I consider good, we were able to reach basically the TypeScript functionalities. We got good data sync. We have API type safety and shared the types to the front end, and also ORM type safety, ORM types that work decently, and they just don't tell us any. Yeah, that's it. Of course, some final conclusions. The TypeScript experience, as I was mentioning before, given that it's the same language, is more standard and it's also more developed, and you have a lot of work on type-safe libraries. But we can see that Python, with these releases, recent releases, is catching up the Python ecosystem. Another thing that I want to see is what happens with Pydantic and the integration that they have with SQLAlchemy. For example, now you are able, in a recent SQLAlchemy 2.x release, you are able to pass a Pydantic data class directly to SQLAlchemy and get that back natively. So that's, I don't know what's going to happen there, but I think there could be some deeper integration between the two. And also there is a project started way before the SQLAlchemy 2.0 release from the FastAPI creator called the SQL model that tries to remove some of the code duplication between the SQLAlchemy models and the schemas of Pydantic. I don't know, I think that the SQLAlchemy support of typing now will give a boost to the project because now you can do more powerful stuff. And yeah, of course, this is a must. Pydantic 2.0 is also coming with a Rust rewrite, so it's epic for performance. Yeah, that's the end.
Questions? Anyone?
I shocked everyone.
Now I'm envious because we're using Django and everyone told me nice stuff.
Can you tell us a bit more about your Django experience?
Like
in terms of compatibility, like the features that you have and you don't have.
This I discovered the other day just for this presentation. But it's basically, the entire motivation is doing something like a FastAPI for Django ORM. Okay. I don't know. It's based on Django REST framework. I don't know if you're aware. Yeah, it's, I guess. And it looks good. I don't know what's the traction or anything, but it's,
So, well, for our Django experience,
you want to come here?
Yeah. I did want that.
Okay, thank you, by the way, it was great. So, sì, ok. No, perché non volevo neanche rimanere abbronzato, capito? Anyway, all right, so to tell you about our Django experience, I think we're using pretty standard basic Django, like the ORM heavily, but probably the ones of you who were at the previous talk know that we abstract that a little bit away, not to be too dependent on the models and do the calls directly on the models. Actually, for APIs, we use GraphQL. So we translate the Django objects to GraphQL objects. There's a library called Graphene.
Okay.
Yeah. Graphene. That does it, I mean, pretty easily. I mean, as of now, it's convenient. Right now, I see this and I think, okay, the TypeScript magic from backend and frontend is very cool.
Yeah, if I can say something, GraphQL, there are a lot of debates between GraphQL and TRPC, for example, on the front end, because some people prefer the GraphQL approach, other people prefer it. It's up to debate and preferences, I guess.
It's a democracy.
Yeah, I said that all roads lead to Rome. There is a lot of stuff out there.
Just ship the stuff, right?
So do you get
Can you use async natively in Django?
Not now. I know there are plans in Django 5 to get it to async.
Yeah, but we just released 4.2, right?
Yeah, I think so. Yeah, I think yes. I mean, I'm sure because I saw a version bump and it broke something. So yeah, I remember.
Last question about Django. Does Django and GraphQL all comply or have a way to spit out OpenAPI specs for your endpoints?
I don't really know. I'm sorry. And by the way, this was his talk, not mine. So.
But no, thank you very much. No, but I mean, if you use mostly GraphQL, I don't know if there is a point to generate the OpenAPI. No, yeah. So it's an alternative, I guess.
You can generate that.
Yeah. Yeah, indeed. GraphQL is the main. Yeah.
I have one more. Can you go on, if you have time, on the setup on the async session and the depends plus annotated points?
Yeah, so that's okay. So I can.
Because it's a novelty, like it came out in FastAPI.
Yeah, I can make an example. I just wanted to develop it the most up-to-date way possible, but of course, I guess it's nice to see what's the difference. So if you take out this part and you put it, it's actually async session equals depends. I think this is the way. Now I don't remember anymore. I just code with annotate. No, I don't. This is the way that you used to declare dependencies on FastAPI until few releases ago. The problem with this is that it's a lot of code repetition. You need to bring everywhere both the type and this depends, say, boilerplate. While now with annotated, given that you declare a new type that has some runtime magic, you can move the depends in the type and just give back the type. So you can, you can just use this everywhere.
Because FastAPI needs to be typed in the request header.
Well, this is not the request header. This is additional dependencies that you need to run the endpoint in some way. Plus, you can add the request with whatever you want. But the main point of the dependency system, I don't think it's necessarily the typing. It's more a very convenient thing for mocking what you have. You don't need to use any mocking library. You just set some global dependency replacements, and it works all straight away. Yeah, no, it's really, you just take the app in FastAPI. I can show it, and you can just change the dependency straight away. Now, I don't use FastAPI that much. As I said, we are envious of this stuff, so.
Just use the SPR.
No, we. So, let's see if we can see something.
The test client.
Yeah, and in the test, you can basically. Let me check dependencies. Maybe it's in dependency.
Ho sentito dal pubblico un commento.
Yeah, exactly. I was trying to find that. Let's see. Okay, yeah, so there is this. Yeah, app dependency overrides, and then you can mock stuff directly without using mocks or anything like that. And also, I guess it allows to structure the app in a bit better way, because you don't have global stuff going around, but the dependencies are very clearly defined. Usually this is called dependency inversion principle, where you pass your dependencies to the functions instead. Inversion. Inversion. Sorry, maybe I said it wrong. Inversion. Yeah, exactly. Same.
Thank you. Sorry, can I ask you? So, do you know how well this plays with my Pi? Because I find it really sweet.
The FastAPI
and all this stuff.
I didn't have. It was working pretty well in my experience. Of course, my Pi, especially with the latest Python versions, sometimes was a bit. I saw some weird stuff. They took a lot to support decently some new features like pattern matching. Yeah, but generally, I think it works pretty well.
So what are you using for checking the types, Pi, right?
No, my Pi and
I think
even because that's more or less the point. So if it doesn't work that well, maybe there is some configuration problems. I don't know. No, but given that it's based on the type ints, if you don't play well with my Pi, it's a bit odd. Yeah.
I think like the author of FastAPI brags about like having a 100% type code base, and I think also 100% my Pi compliant code base. So should natively be compatible. There are always edge cases.
Okay. No.
I was curious about testing. I mean, how the async stuff plays well with test runners like PyTest.
I don't have much experience in that because I'm not using it that much day to day. So I think there are all sort of contexts and a way to work with it, but sorry.
You know, like, so I was reading through the Django 5 something release, and they said that the problem was to have the database driver which was VDSync.
Sorry, database? Okay. See. Yeah, you need to, even in this case, you need to install drivers that like async PG or stuff like that. Otherwise, it will not. Yeah. Yeah. Also. Yeah. In this case, I was pretty basic. I think I used the IO SQL. I don't remember how it's called. IO SQLite. So in this case, yeah, you need. Okay.
Okay, thank you very much. As usual, afterward we will go to take a beer. To be clear, everybody have to pay their beers, so it's not offered. And it's Casbel 0. It's 600 meters at the end of Via Solferino. So we book 15 places. So if you want to come to join us for a beer, yeah, exactly.
Okay, thank you for the night. Thank you for your hospitality. Thank you for the great presentation. See you on SEDICD.
We will have a new meetup in May. I think in a month time frame. Thank you. No, before.